Okay, hi everyone. So today in this video, I will be discussing solutions to the problems of Educational Code Forces Round 151. So I will be discussing the first four problems. So let's begin. Okay, this is problem A, forbidden integer. In this problem, you are given an integer n, and you are given an integer n which you want to obtain, and you have an unlimited supply of every integer from 1 to k except integer x. And what you have to do is to like take some amount of each of these integers such that their sum is equal to n. Okay, and you have to print either yes or no, and if it is yes, you have to print how many total numbers m you will take and each of those numbers. Okay, so let's see what we can do for this. So, so let's see that you are given all the numbers from 1 to k, right, except x, and you have to make finally n by choosing some elements within this range except x. So the first thing which you can notice here that if k is equal to 1, okay, then definitely x will also be equal to 1, because in the constraint it's given that x lies between 1 to k. So if k is 1, then x would be 1, which basically means you can't take any element. So definitely you won't be able to make anything if n is given. Okay, so this is the constraint given. So if k is 1, x will also be 1. And so in this case, our answer will always be no, because it ideally means you can't choose any element. So you won't be you won't be ever able to make n. This is the first case. Let's see the second case. The second case is if k is if k is equal to 1, your answer is no. Then the another case will definitely k will be greater than or equal to 2. Now if x is not equal to 1, so in this case our answer will always be yes. How? We will simply print 1 n times. Okay, since x is not equal to 1, you can always choose 1. So if you choose 1 n times, you will always be able to make n. Okay, so this is the second case, that is if x is not equal to 1. The third case, which definitely occurs only if x is equal to 1. So if x is 1, and let's say that my n is even. Okay, let's say n is even. So n is even. Okay, so if x is 1, right, then definitely k will be at least 2, right? So if n, and if x is 1, k is at least 2, and n is even, then in that case you can print to n by 2 times, n by 2 times, right? So this is the third case. The fourth case which you can see here is that if x is 1 and let's say n is odd and k is also 2, so in that case you won't be ever able to make n. Why? Because x is 1 then and k is 2, then you have to take only 2. So by using only 2's you can't ever make an odd number. So in this case your answer will be no. Okay, otherwise what it means is that x is 1 and my k is not 2, so k is at least 3. So it means we can choose numbers like 2 3, at least 2 3, right? Now it can be proven that by using only 2 and 3 you can make any number n, right? So the case of n is even is already covered here, right? So we are only left with odd numbers. So how we can make odd numbers? So let's say we want to make 5, right? So we can write it in terms of 2 and 1 like this. Okay, now if you just club these 1 and 2, you get 2 and 3, right? Similarly, if you write any number 7, so 7 can be written as 2 threes, sorry, 3 twos and 1 1. Now you can combine this 2 and 1 to form a 3. Okay, so in this way, by using 2 and 3, you can write any number, any odd number n. Basically, if you see that how many twos you will need n by 2 minus 1 twos, right? And then there will be one number which will be equal to 3. Okay, so by using this way, you can always make an odd number. Okay, so these were a couple of cases that you need to handle one by one, right? And ultimately you will be able to print yes or no. So does anybody have any doubt in this? Okay, So if there are no doubts, then we can move to its code. Okay, so here I am just simply checking, simply taking n, k, and x, then checking the first condition that if k is equal to 1, then it's always not possible, right? Otherwise, I am checking if x is not equal to 1, right? So if x is not equal to 1, I will simply print 1 n times. So I print yes, then n, and then I print 1 n times, right? Otherwise, I check if n is odd, okay? If n is odd and k is equal to 2, then it will be never possible, right? Otherwise, I check if n is even, then I simply print 2 n by 2 times. So there will be n by 2 numbers. So I print 2 n by 2 times, right? Otherwise, it means that n must be odd and k must be at least 3. So in total, how many numbers would I need? I would need n by 2 times, right? N by 2 total numbers. So I print yes, then these many numbers. So I print n by 2 minus 1 times 2 and then 1 times 3. So as you can see, in total, you need n by 2 minus 1 plus 1, that is n by 2. So that's why total in this case will be floor of n by 2. Okay. So this is clear to everyone, right? So we can move to the next problem then. So this is problem B, come together, right? So in this problem, you are given that Alice, Bob, and Carol live on an infinite 2D grid in cells A, B, and C. And right now, all of them are in cell A. And Bob is in some cell. He or she can move to the neighboring cell. So it's given that from any cell, you can move to any of its adjacent neighboring cells, right? That is top, left, up, and down. Now, what we want is that Bob wants to move to the cell B and Carol wants to move to cell C, and both of them want to go along the shortest path, right? That is, which takes minimum possible number of cells, but they would like to work together as well. So we want to find what is the maximum possible number of cells that Bob and Carol can walk together if each of them walks home using one of the shortest paths. Okay, so let me explain this problem for you. So in this problem, what we are given is that we are given some initial coordinates. So initially, we are given an initial coordinate, right? So each of Bob and Carol is standing on this coordinate. Okay. Now it's like that Bob has to move to some XB, YB coordinate, and Carol has to move to some coordinate XC, YC, right? Okay. Now Bob will move in such a way from this to this such that it takes minimum possible number of steps. Okay. This path length should be minimum. Okay. This path length should be minimum. And in fact, you can say that this path length will be nothing but the Manhattan distance between these 2 points, right? Similarly, Carol will also move from this to this point using the shortest distance path. Okay. Now what we have to do is that we have to move Bob and Carol such that their overlapping cells is maximum. That is, those cells where Bob and Carol both visit that cell should be maximized. The number of cells which are visited by Bob and Carol should be maximized together. Okay, so if Bob is also visiting this cell and Carol is also visiting this cell, then the type of these cells should be maximized. Okay, so let us see how we can do this. So let's say if your initial point was over this point, right? And let's say Bob want to moves to this point, and let's say Carol want to moves to this point. Okay. So what you can see, like, okay, Bob and Carol. So Bob can move like this. Okay. And then let's say Carol moves like this. Okay. So you can clearly see that this part is overlapping between them. Okay. So this can be counted as the cell which are together visited by B and C. Okay. And it is never beneficial for Bob to move like this, because if Bob moves like this, then there is kind of no overlap. right? Similarly, if Bob moves like this, then their overlap is not maximum. Okay, so what you can see from this diagram is that if you see here that you can actually calculate the overlap in this case, and that will be nothing but this. This is the overlap, right? So this was like XA YA, this was XB YB, and this was XC YC. So you can calculate this difference, right? This difference, and you can also calculate this difference and take the maximum of the minimum of these two. Okay, but what happens if this overlap is, as you can see, is horizontal. Okay, this overlap is horizontal, but there is no vertical overlap. Now if you consider a case like this, that your initial point is this, and let's say Bob is at here, and let's say this is Carol is at here. So you can move Bob to this like this, and you can move Carol to this. So in this way, you see the overlap is vertical, and in this case, it is this much. So if XA and YA are given like this, you can calculate the horizontal overlap, that how much horizontal overlap will happen, and then how much vertical overlap will happen. Okay, and then you can simply add them together. Now you can see that horizontal overlap here is occurring only because the y coordinates of these are in the same side of this. Okay, like if it was the case like Bob is at here and Carol is at here, then in that case there would be no vertical overlap, as you can see. Okay, there will be no vertical overlap, right? Similarly, if they lie on the different side of like their y coordinates, so let's say this is my initial point and Bob lies here and Carol lies here. So in this case, you can see that there will be no horizontal overlap. Okay, there is only the vertical overlap. Okay, so so basically you can just calculate what is the horizontal overlap, right? Horizontal overlap happens only if their x coordinates lie in the same side of XA, and similarly vertical overlap happens if the y coordinates lie in the same side of this initial point, right? And then you can just add them together, and you also need to increment that by 1 because initially you are standing at the same point, that is XAYA. So this is a cell which is initially visited by both Bob and Carol. So you also need to account for this cell, so you add 1 to your final answer. So the final answer will be horizontal overlap plus vertical overlap plus 1. Okay, so does anybody have any doubt in this? So I can show you the code that will make the things more clear. Okay, so you can see here I have taken XAYA, then XBYB, then XCYC. Now I am first calculating the horizontal overlap, and then I'm calculating the vertical overlap and incrementing it by 1. So I have written here the code for calculating this overlap, right? So basically the first coordinate is the initial one, and then the other ones are the coordinates of Bob and Carol. So I am first checking that if, so X is the initial coordinate, right? So if Y and Z are both greater than or equal to X, it means that both of them lie to the right side. So if Y is greater than or equal to X and Z is lesser than or equal to X, I return the minimum of Y minus X and Z minus X. Similarly, if both of them are lesser than X, then I return minimum of X minus Y and X minus Z. Otherwise, I return 0. Because as I said you, if they lie on the different side with relative to their coordinates, then I would never be having any overlap. So I return 0 in that case. So just calculating horizontal and vertical overlap and incrementing the answer by 1 for accounting the initial cell. Okay. So somebody is asking if problem D is going to be discussed. Yes, I will be discussing problem D. But currently, do you have any doubt in this? Okay. So if there are no doubts, we can move to the next problem, right? So this is problem C. So strong password. So in this problem, Monokar finally got the courage to register on Codeforces. So he has to build a password, right? And the password has to satisfy these three properties. Now the three properties are like, first of all, the length should be exactly M. Then it should consist only of the digits from 0 to n, 0 to 9. Okay. So it's a numeric password. And the password should not appear in the password database given as a string S. Given as a string S as a subsequence. Okay. So you're also given a string S, and you have to ensure that password should not be occurring as a subsequence in string S. And apart from this, you are also given two um, other strings of length M, that is L and R. And what we want is that the ith digit of the password should be between Li and Ri. And we have to check whether there exists such a password which satisfy all of these criteria or not. Okay. And the constraint are like M is pretty much small, like only 10, which is the length of password is very much small. So let us see how we can do this. Okay, so basically you are given some string S, okay, and the length of this string is n. Now we have to build a password P, okay. The password should be of length M, and it should be built in such a way that it should not occur as a subsequence in this string S. And also each of the ith digit of this password should lie between Li and Ri. Okay, this restriction should be maintained. Okay. Now let us first try to see that if we are given some string, let's say we are given some string Codeforces, okay, and if we are given some string T, let's say we are given some string like CORS, okay, and if we have to check whether T is occurring as a subsequence in S or not, then how do we check? Okay, how do we check whether this string is occurring as a subsequence in this? So for checking whether T is a subsequence of S, you can start with C. So what is the first place where C is occurring? So you see, okay, C is occurring here first time. Then you check for O. What is the first occurrence of O to the right of this C? So you get this O. Then you have to check for R. What is the first occurrence of R to the right of this O? So you get this. And then you finally you have to check for S. So what is the first occurrence of S to the right of this R? You get this. So in this way, if each of these characters is occurring, like if you can find each of the occurrence of these characters to the right of this, so you can say that yes, this string is occurring as a subsequence in this. Otherwise, you can say it's not possible, right? So what we will do now is that we will start filling each of the digits one by one. So it's like there are M digits in the password, and we have to try to fill each of them one by one. So let's say we are at the first digit. Okay. Then we will definitely be filling from Li to Ri only, because this digit can be only within this range. Okay. So you have to choose a digit from Li to Ri to put at this place. Okay. So if this is the initial position, right? If this is the initial position, so let's say I try to put here 2. Okay. So in the string S, so let's say string S is some numeric. Yeah.
Sir, but it is possible that we can find this in subsequence when R has the first occurrence, but O has the second occurrence like that.
Yes, you can find this, but what I'm saying is that it's never optimal to kind of choose a choose a distinct, or like choose the right word occurrence. Like it might be possible that okay, you are choosing like this O. Let's say you are choosing this O. Still you are able to form course. But if you don't choose this O and choose this one, still you are not at the worst. Like, right? What it's not worse to choose this O as well, because if you can do with this O, you can also do with this O. but but suppose instead of this C which I am mapping to here, if I try to map this C at this position, will I be ever able to make this course? No, right? Because if you map this C saying match it at this position, then
Sir,
you won't
sir,
be
I
able
am
to
not
match O.
able to understand it. Can you explain again?
Okay, just a minute.
Hello.
So let's say your string S is code forces and your string T is course like this. So you have to check whether this is occurring as a subsequence. So you will first check for the occurrence of C. So C is occurring at this place also, and it is occurring at this place also. So which place it is better to choose? Definitely the first occurrence, right? Because if you make your C at this, if you match C, this C with this C, then your O will have to be mapped to the right of this C. Okay, and there is no occurrence of
Yes, sir.
O. So that's why if you choose the leftmost occurrence, so you choose this C, then after that you choose O, which is just to the right of it. So best is to choose this O, okay, and not this O.
Oh,
It might be so. Although you choose this O, you choose this R, and you choose this R, still you are able to do. But what I'm saying that if you don't choose this O and choose this O, it is still like not bad, right? Rather it's giving giving you opportunity to match all the other characters, right?
yes.
So that's why I was telling this is the process of matching the subsequence. Okay, now let us come
So
to the
like we are choosing the first occurrence, right?
yes, always choose the first occurrence.
Okay, okay.
Okay, now you have to form, now let's come to the original question. Now you have to form a password of length m, right? So while you will be forming your password, let's say you formed your password like this. So how you will match it? How you will match it? So basically, let's say this is 8. So what you will do, you will find the first occurrence of 8. Let's say 8 is occurring here in your string as first time. Then 1. What is the first occurrence of 1? Let's say 1 is occurring here, right? You will be doing like this. Okay. So what we will do, we will basically maintain, let's say, a first array. Okay, we will maintain a first array. So first, so before making a first array, let's try to simulate the process of forming the password. So let's say that we want to form the first place. We want to fill the first place of our password. Okay, so in order to fill this place, so I can fill any number from Li to Ri at this first place. So let's see if I fill here 8. So what I will do is that I will try to check whether 8 is occurring in this string or not. And if it is occurring, what is the leftmost occurrence? So for example, in this case, I will get this index, right? So I will simply say that first of this 8 is equal to whatever is the index I am getting. Okay. So in this way, I got my first of 8 like this. And similarly, if you try to put here 1, you will be getting first of 1 as this, right? Now try to fill the next position. Let's say you try to fill the next position. So again, you try to fill all the position, all the digits from Li to Ri at this position. Suppose you try to place some digit x at this point. Okay, so how you can calculate the first of x, that is where is x occurring in this subsequence first. So what you can do, you can just iterate on the previous character or the previous digit which you would be filling here. Okay, so let's say you are saying that I am filling 8 at the previous position. So then you will say what is the first occurrence of 8. So you get the first position of 8 like this. Then you have to find what will be the first position of x after this 8. Okay, so let's say you found this, that okay, x is occurring here first time. So you will say that yes, first of x can be this, can be this. Okay, so in this way, what you will do, you will try to always maximize the position of first. Okay, because you don't want that this password should become a subsequence of string s. So what you will try to do is that while filling each of the digits, you will try to like if you try to put x at this position, you will try to fill the previous position digit in such a way that the first of this x got maximized, because it's freedom up to you to fill the previous digit. Okay, you can choose any digit to fill the previous digit. So obviously you will always try to choose such a digit to fill the previous one, so that if you are putting x at this position, then your first of x is maximized. Basically the first position of x will be maximized. Okay.
But how will we know that? How will we know the sequence of the string that if you put x this value that it will be maximizing its index? Since I'm not getting that, how will we know that if we put greater
Okay.
value then?
Okay, so let me again show you.
Also, like, what are we doing with the first of index array? I'm unable to understand that part also.
Okay, let me show you. So let's say your string s is like 1281321 like this. Okay, and this is the password. Okay, so basically what I'm saying is that, let's say I have filled digits up to this one. Okay, and let's say I am putting digit x at this position. Okay, so what I am trying to say is that you can try to fill any digit at the previous position, but at the end you are putting x at this position, right? So what I am trying to say is that, what is the maximum position of x which can be traced as a subsequence in this string? What is the maximum position of x which can be traced as a subsequence considering this string into this one? So let's say if your x is equal to, let's say if your x, so let's say we are filling this position. So let's say my x is equal to 2. My x is equal to 2. So I have to fill this one also. So let's say if I fill 1 here, right? So 1, 2. So if you try to match 1, 2, you will get the position of this 2 as here, right? But if you try to fill this like, let's say 8, 2, then your position of 2 will be like 8 is here, 8 is here, and then 2 will be here, right? Similarly, if you try to fill this with 3, 2, 3, 2, then you get like this. Okay, so why I'm doing this is that, like, if you know that I am filling this position with 2, then of all the subsequence, or like of all the passwords which is of length I and which is ending with the digit 2, what is the maximum what is the maximum position where this 2 can be matched with in this string? Why maximum? Because I want that this complete string should not be a subsequence. So that's why I am trying to maximize the position of matching, so that if let's say I get an 8 over here, but since 2 is occurring here, I can't get 8 to the right of it. Okay.
Hello.
Mhm.
But like, filling up a particular position in a password depends upon the value of li and ri. So like if for a particular position, if 8 is not between li and ri, how will we doing how will we doing in that case?
Yes, so basically what I will do, that when I am filling the position number I, so I try to put all the digits from li to ri. Okay, so x should always be belonging within this range, and I calculate for each x which belongs to this range, if I put x here, what is its maximum position? Okay, and for calculating it, let's say I am putting x over here, so I iterate on what should be my previous character, or sorry, what should be my previous digit. So let's say I'm saying my previous digit is y, so I calculate that what is the last position of this y. So let's say the last position of y comes out somewhat here. So after this y, what is the first occurrence of this x? Okay, so for a given x, I iterate over all the y's, find the first occurrence of x to the right of the first occurrence of y, and then maximize that value.
Sir,
Hello,
but
sir.
our
Mm-hmm.
work will be over if even if we get only one difference of one, because if there is difference of one, then also it will not be a subsequence.
I didn't get your like point. Can you
Like
repeat?
there is one character between both of them,
There is one character between both of them where
x and y. So then also it won't be a subsequence.
there is one character between X and Y. No, Leon, no.
So between
X and
Li
Y.
and Ri.
See, so what I'm saying is that for this fixed position, okay, only for this fixed position, I try to fill all the numbers from Li to Ri. Let's say I fixed, okay, I will be putting here X. After that, I try to find that of all the sequences which are of length I, okay, which are of length I and which ends at X, okay, which ends at X. What is the maximum possible like position of matching that X can match to, considering all the ways of filling the previous digits?
Okay. Yes.
You got my definition. Like what I'm saying is that, like for a given position I am saying that for a given position I, if I try to fill this position with some number, some digit X, which lies between Li to Ri. So considering this entire password of length I, what is the maximum position where this X can match to in this subsequence? So I already taught you like how you match a subsequence. Okay. So if you consider that way of matching, then where will this X match to? And what can be the maximum such position of X matching?
Yes.
So
Okay.
that means for
Huh.
every value from Li to Ri, we are checking the maximum.
No.
For
I am not checking for every Li to Ri. I fix some X. Okay. So it's like some array, DP array, you can say DP array. So DP of X kind of DP of X will say that, and this DP of X will be particular to this position only. Okay. So at this position, if I put X, then what is the maximum possible position of matching of X?
Can you please show the code? Maybe that will help.
Yes.
Yeah.
Hello, sir. One doubt. Like in this example only, 3215 is a valid answer, right?
3, 2, 1. So what is your
5.
X? So let's say you
No,
are saying,
in
let's say
this
you're, yes.
example only, if I tip,
Uh,
if there are like four digits, like M is
mhm,
4,
mhm.
then if I write 3215, means it is okay or not?
3, 2, 1, 5. Yes, it is okay
Yeah,
because you
yeah,
won't be
okay,
able to
that
match
was
it.
it.
So basically, if you won't be able to match it, so in that case, you can say that it matches to index n. If you're considering zero-based indexing, you can say it matches to n. So that's what at the end you have to check, that if like if at the last digit, if you try to fill this digit with X, and if you are saying that maximum position where it can match to is n, it means your answer is yes. So let me first show me my code. Maybe that would able to make you understand more. So basically what I am doing is that, first of all, I am maintaining one ID. Okay. So ID is like of length 10, and it is basically a vector. So ID of I will maintain all the positions where I is occurring in string S. Okay. So I iterate over all the characters of string S. So let's say the current value is val. So ID of val dot push back I. Okay. So for every digit, where is it occurring in the string S, I am maintaining all such positions in my ID, right? Now I am maintaining a first array. Okay. So initially it is all initialized with -1. Okay. Now I am trying to fill each of the digit one by one. So let's say I am trying to fill the ith place. So what will be my L value and what will be my R value? I'm storing it in L1 and R1. Then I am declaring another array called new first. Okay. So this will act as a previous first, that is the first corresponding to I minus 1, and this is like a new first array. Okay. Now let's say we try to iterate on each of the numbers from L1 to R1, because at the ith place I can fill numbers from L1 to R1. So if I is equal to 0, it means that we have to fill the first place. So I check whether ID of j is empty or not. Okay, if ID of, so I'm trying to fill with digit j, and if there is no occurrence of j in your string s, then definitely the the first matching of j will be equal to n, because you are not able to find it anywhere, so you went to the end of the array. Otherwise, my first occurrence of j will be simply whatever is the first, or like the smallest element in your id of j vector, right? Otherwise, what I do is that if I is not equal to j, so I iterate on each of the previous possibilities. So I am putting here j, but what is the digit I could have put previous to j? So let's call it jj. So if first of jj's, right, if first of jj is -1, it means that you can't ever put jj previous to j. So you simply continue in that case. Otherwise, what you do is that you find the first occurrence of jj, and you have to put j after jj, right? So you try to find the upper bound of 2 in the vector id of j. Okay, and if you can't find any occurrence of j after jj, your first occurrence of j will be n. Otherwise, first occurrence of j will be simply asterisk of iterator, and you take the maximum over all such possibilities. Okay, and at the end I just swap the first of j and new first of j, because so that this new first can act as a first in the next iteration. Okay, at the end I just check for all the digits from 0 to 10, that if first of this is equal to n, I print yes, otherwise no. Yes, so it's a kind of like DPU, you can say that, where we are trying to say that if I am having like I positions filled, so if my password is having I positions filled, and if I am filling this ith place with digit x, then if I try to match this x, so let's say if you try to match all these digits, so where will x be mapped to? What is the maximum such position of mapping? Okay, we are trying to do that. Where can be the where it can map to at maximum such position. Okay, if you try to match this in the way I showed you, like how we match a subsequence in a given string, right? We try to find first of all the first occurrence, then the next occurrence of it just to the right of it. So like in that way, if you try to find the first occurrence of this x, then what can be the maximum such position? So if at the end the last position, if you fill with x, and if its first occurrence is n, it means that this entire password will not ever occur as a subsequence. So somebody is asking, we are choosing x such that in the matches subsequence x will be in the rightmost position. Yes, it should be as much right as possible. So let's say you are given like two. Let me give an example. Yes, this example, and let's say you have to make a subsequence such that it ends with 3, and let's say there is no restriction on LNR. So if you try to make a subsequence, let's say 1 2 3, then where will you match this subsequence? So you can match this subsequence like this: first occurrence 1, then after it 2, after this 3. So in this way you get this as your position of 3. But let's say if you make your substring like this, that is you make it like, let's say there was some 8 also here. So if you try to make it 8 2 and 3, so in that case your first occurrence of 8 is here, first occurrence of 2 is here, and first occurrence of 3 is here. So in that case your first occurrence of 3 gets to this position. So what I want to say is that this is not a good one. So 8 to 3 is not a good one, rather this is a good one, because if you match this subsequence, your position is as much right as possible. Okay.
So for a particular index, why can't we take the value from Li to Ri whose index is maximum, means the position of that value, where it will fail?
No, it will not fail. So basically, for you are saying right that for ith position, let's say we tried to put all the numbers from L to R, okay, but you just don't have to take maximum, because your entire password will be formed of length m, right? So you have to check for the last word, not this word only. So that's why here you have to maintain the first occurrences of all the numbers from L to R. So you will try to put all the numbers x from L to R, and you will just store it. Okay, just store it in some kind of, I am not calling it DP, so because in my code I have called it NF. So just store it in an array NF of x. Okay, so this NF of x will be only for this index. So NF of x will be only for this index, that if I put x at this position, where will be it matching to, like, rightmost position where this password of length I ending at digit x, where rightmost it can match to. Just store it for all the values of this. Okay, and when you move from this to this, simply like update your first with this. So first will be storing for I minus 1th position. This the same thing for I minus 1th position. NF will store for the ith position. So when you move from I to I plus 1, you just swap these, like the first will be like swapped with, or like assigned with NF. So we just like update the value of this array. Okay. So this was for problem C. Now its time complexity is not that much. Basically, if you can see, we are iterating on M, then we are iterating for from L1 to R1. So it's like M into, like, L1 to R1 can be like 9 digits. So M into 9 into again a 9 and then an upper bound. So it's like M into 9 into 9 into log of n, kind of. Okay. So is this clear to everyone, or does anybody have any doubt in this?
I also solve this using a similar approach. For
Yes.
every index, I just stored key the next index. For every index I maintained that 0 to 9. When is the next 0 to 9 occurring? So जब मेरे को फर्स्ट अपना फर्स्ट कैरेक्टर चूज करना था, सो आई चोज द in that limit L1 to R1, the marks, the one having the marks index. फिर ऐसे ऐसे कर करके I did this. But I guess वो उसकी टाइम कॉम्प्लेक्सिटी ज्यादा होती है इससे.
हाँ, मतलब ऐसे डायरेक्ट मैच करोगे तो फिर मतलब टाइम ज्यादा हो सकती है, इसलिए मैं अपर बाउंड यूज कर रहा हूँ कि फर्स्ट ऑकरेंस टू द राइट ऑफ समथिंग, लाइक जस्ट उससे बड़ा कहाँ पर है, ऐसा. Okay. So let us now move to problem D. Okay. I can see. Okay, somebody is asking me to explain the else part of my code. So sure. So if I is not equal to 0, okay, if I is not equal to 0, let's see. So if I is not equal to 0, let's say you want to fill this place. This is the ith place. Okay, this is the ith place. So I am trying to fill it with all the numbers. So currently I am trying to fill this position with J. Okay, so the outer loop is on J. So let's say I try to fill this position with J. Now what I am iterating on the previous value. So what will be the digit at the I minus 1th position? So let's say this digit is JJ. Okay, so I iterate on the previous digit. So once I iterate on the previous digit, I check if first of JJ is equal to -1. If first of JJ is -1, it means that it's never possible to have JJ before J. Okay, so I continue. Otherwise, I try to find that, okay, what is the rightmost occurrence of this JJ matched as a subsequence? So let's say this position is, I am calling it as 2. Okay, then what I'm trying to find is that what is the, like, first number, like first occurrence of JJ to the right of this. So that's why in ID of J, which is ID of J will basically a vector denoting all the positions where j is occurring. So in that vector, I am trying to find the upper bound of 2 so that I can get the first position where j is occurring. Okay, so if iterator is equal to id of j dot end, it means that there is no j anywhere in this array. So kind of you iterated all through this and you don't get any j. So in that case, I set nf of j as n. Otherwise, I maximize nf of j. So nf of j is maximum of nf of j, and like whatever position of j I got. So let's I got this position. So I just take maximum of nf of j and asterisk of iterator. So you see, maximum is taken over all the previous digits.
So my doubt is why you take the upper bound for the JJ. I mean, can't take the first JJ occurrence.
No, first JJ occurrence can't be taken because uh, if I am putting here j and previously I have put jj, right? So wherever jj was occurring, I must take j after that, right? I must take j after that. So that's why I'm taking upper bound. That is, wherever jj is occurring, it should be the position of j should be greater than that. That's why I'm calculating upper bound.
So upper bound, you calculate upper bound for the position of J or JJ.
I calculate on the position of jj because position of jj is kind of I have already previously calculated. Position of j has to be calculated now. So I find on the upper bound on the position of jj because what is first which is greater than the position of jj. So 2 is holding the position of jj. So that's why just greater than 2. 2. So upper bound on 2. So it's actually upper bound on 2.
Understood.
Did you get it?
Yes.
Okay.
Is this digit DP?
No, this is not, I would say, digit DP, but similar to digit DP and like searching, basically greedy kind of. It's more like a greedy stuff. But yeah, it's kind of digit DP. DP is also kind of involved because we are storing this first occurrence of each digit at each position. So we are kind of memoizing as well. So we are also using the previous states as well. You can see that we are using this first and NF. So first is storing for the I minus 1th digit, what are all the rightmost occurrences corresponding to each digit. So yes, it's a kind of DP, but not sure it's not digit DP because in digit DP we have to like iterate on all the digits and do some transition. Yes, similar to digit DP, you can say.
Okay, okay. Yeah, what would be the rating of this question? What do you think?
I think 1600 or 1700 maybe.
Sure.
Yeah.
Can we like brute force this from by traversing between L value and R value and then matching it with like whether that like present in the subsequence or not? I'm
So
talking
that
about the
would be
brute
like
force. Yeah.
brute force, like LNR, like around O of n for each position. Then 9 to the power m. M is 10. So 9 to the power 10 would time
Oh, okay,
limit
okay.
exceed. So that's
Yeah,
why
yeah.
you have to memorize it, right? So for each position, we are trying to memorize it. Like if I try to put at ith position digit x, what is the rightmost occurrence where this x can match to, considering only the first I characters. So this is what I am memorizing in NF.
Okay, okay, okay.
Okay. So let us move to the next question, which was problem D. Okay. So in this problem, initially you are given a player and his rating is 0, and there are n matches, and after the ith match, the rating change is equal to AI. If it is positive, it increases; otherwise, it decreases by this absolute value. And there are no zeros in the sequence A. Now, there are also additional rule that if for a fixed integer k, if the player's rating has reached the value k, it will never fall below it. Okay. Formally, if a player's rating is at least k and a rating change would make it less than k, then rating will decrease to exactly k. So basically, your rating can't ever fall below k. Your task is to determine the value of k in such a way that player's rating after all the n matches is maximum possible. Okay. So let us see what we can do for this. So here you are given an array like A1, A2, A3, so on and so up to N, and your initial score is 0. Okay, and each time you play, you basically add these values to your current score. And if at any time your current score goes below K, right, then you simply set your score to K only. Okay, so basically your score can't ever go below K. If it ever tries to go below K, it simply becomes K at that point.
नहीं,
Okay.
but what if it's already below K? मतलब, if it's, for example, if K is 5 and we have
Yes.
0, 3, -2, then it would become 1, right?
0 minus 3. No, yes. If it ever goes below from above to down. So
Yeah,
it
exactly.
yes.
Okay.
Yes. So it should not be happening that before adding some score, the current score was greater than K, and after adding this score, it is going below K. So if it ever happens such, then it will simply become K at that point. But yes, if it is already below K, then nothing would happen. So let's say you are setting your limit to some K. You start with some score 0, okay? And let's say you add some score, let's say it goes here, then let's say it goes here, then let's say it goes here. And from here, if it goes somewhat here, okay, by adding some AI, if your current score goes from here to here, then this won't occur, and you will simply reach at score K only. Okay, even if you try to go below it, it won't happen. You will simply remain at score K only. It might happen that you get increase, but it will never try to, like, if it can't ever go below K. Okay, this can't happen. This will simply reach till K only. But yes, it can remain below K if initially it was below K. Right. So let us see how we can do for this. So let's try to see that if some K is fixed. If K is fixed, then how do we solve it? How do we find the final score? So let's say these are your AI values. So what you try to do, you try to add all the values from starting from here. So you try to add, try to add, try to add. Let's say when you reach this point, then let's say your current score goes below K. So in that case, you can simply say that your current score or will simply become K in that case. Okay. Then after that, you again try to move ahead. Okay. Let's say you try to add these values, these values, these values. And let's say if this goes below 0, okay, this segment sum goes below 0, then definitely you can say that you can assume that the sum of this segment would be 0. Why? Because see, from here to here, it is K. And if the sum of this segment is lesser than 0, then overall, if you try to go from here to here, your sum will become lesser than K. But in that case, you have to make it K. Right? So you can assume that for any segment whose sum is like lesser than 0, you can assume that actually it will be counted like 0 simply. Okay. So this segment is having a sum of lesser than equal to 0. Again, you try to move ahead. Once you reach a condition or point where the sum of segment is lesser than 0, you simply stop and say that this will also be counted as 0. Okay. And at the end, what will happen is that your final this segment sum will be something greater than or equal to 0. Okay. So in this case, your final answer or your like final score will be nothing but K plus like whatever is, let's say, is this delta value, K plus delta. So did you get this, like how we get for a fixed value of K, what will be the final score? So it's like we first started with current sum of 0, current score of 0. We keep on adding these AI values. As soon as we reach a value which is lesser than K, okay, and let's say earlier it was greater than K, of course, earlier it was greater than K, but upon adding this value, let's say it goes below K. So in that case, let's say, so your current score will be simply K in that case, right? After that, you try to move from the next point. And once it goes below 0, so you try to add these values. And if it goes below 0, you can assume that the segment sum of this will be 0. Again, you try to add the next subsequent values one by one. If it segment sum becomes lesser than 0, you can say it is 0. Okay, and at the end, if some positive suffix sum is remaining, let's call this suffix sum as delta, your final answer will be k plus delta. Did you get this?
Okay, so here you're just calculating the answer for a k, right? Matlab, what's
Yes,
the
yes,
maximum sum that we can get? Okay.
yes. So this is the way you can calculate for a fixed k. Okay, now actually what you can do by seeing this is that you can calculate this delta as maximum suffix sum as well. Okay, so so what observation you can do is here is that this delta is nothing but maximum suffix sum on AI values which start at or which start at a point greater than or equal to I. Okay, so let's say uh, if this was the position I, okay, and if you have to calculate this delta, then this delta value will be nothing but the maximum suffix sum. So you consider all these suffix sums and your delta will be the maximum suffix sum among all those segments which start to the right of I. Okay, now why it is so, it's like that for a given k, for a given k, you know that it will look something like this, that is first segment will be having a sum of k, then there will be some segment will be having a segment sum lesser than 0, and at the end something will be greater than equal to 0. Now if you consider any suffix sum which is maximum, so it will never overlap with any lesser than or 0 segment. So let's say if I am considering this segment, and if I am saying that this is having a maximum sum,
So just a
then
second, can you take an
yes,
example here? I mean, matlab,
yes, yes,
meko
yes.
the segment wala less than 0, I'm not able to
Okay,
understand
okay.
this. Yeah.
Let's say your value is like this. Let's say 2 minus 3, 4 minus 6 minus 5, 2 minus 6. Let's say like this. And let's say I am setting k to be equal to, let's say, 2 in this case. Okay. So you start with 0, right? Then 0 plus 2 is 2. Then 2 minus 3 is minus 1, right? So you can say that this segment is having a value lesser than or equal to k. So which means that after adding these two values, your like value at this point will not be 1 but minus 1, but rather it will be 2 only,
Okay,
right?
yeah. Hmm.
After that you will try to add these values, like 2 plus 4 is 6, then 6 minus 6 is 0, then 0 minus okay, again you see it becomes 0. Okay, it
Hmm.
becomes 0. So it becomes 0, so it will again be converted to 2 only, right? It will again
Hmm.
be converted to 2 only. So see, from here to here, you know that the sum is 2, right? After that, you have tried to add this. But see, as soon as you reach there, your sum is getting minus 2.
Hmm.
Okay, and here it was k. So that's why I'm saying that if this sum is lesser than 0 and here it is k, so k plus anything which is lesser than 0 will make k lesser than k.
Yeah.
So that's why I'm saying that virtually you can say that this segment has a sum of 0 whenever it goes below 0.
Okay, but how do we determine the segment? Matlab, I can always extend this segment to -5 or 2 or -6,
No, no,
right?
no. See, as soon as you reach a negative value, you stop at that very point. So, for example,
Okay.
here it is 4. 4 minus 6 is minus 2. Stop at this point. So, this
Okay.
made a segment. Again, start at minus 5. Okay. Stop at this only point.
Okay.
Start at 2. 2 minus 6. Again, this will be a segment.
And I mean, what's the logic of distributing this into segments?
Because, see, at the end, like all these segments will contribute nothing. But if at the end your segment is having something greater than or equal to 0, then your final answer will be like k plus whatever is this segment sum,
Okay.
right? Because
Mm.
each of these segments will make your k lesser than k, so they won't contribute anything.
So, I mean, for doing this, can we do this? Matlab, we can just maintain a prefix array, and then for every k, we just find the first index that has its value greater than equal to k, right? And then from that, from the next index to the last index, we just take the maximum suffix from the like a segment tree or matlab we can just do a maximum suffix, no?
Yes, yes.
So अच्छा, but can we use ternary search here? Like मेरे को ternary search strike हो रहा था, पता नहीं क्यों, मतलब
I don't think like ternary search, मतलब ऐसा कुछ ternary search का फीलिंग ऐसा आ नहीं रहा है, मतलब इसमें
मेरे को
ना ही
ऐसा लग रहा
binary
था
search
कि
का। हाँ
मैक्सिमाइज करना था। तो
हाँ
इफ अगर मैं k को बढ़ा दूं तो भी वैल्यू कम हो जाएगी, और घटा दूं तो भी वैल्यू कम हो जाएगी। तो मतलब देयर वुड बी एन ऑप्टिमम वैल्यू ऑफ k दैट वुड गिव मी द मैक्सिमम वैल्यू ऑफ द सेगमेंट, राइट? तो दिस वाज माय आइडिया,
आई
बट
डोंट थिंक लाइक इसमें ऐसा जरूरी है, क्योंकि के को स्मॉल कर देने से या के को बढ़ा देने से ये मतलब ये सब जो सेगमेंट्स है ना ये आगे पीछे हो जाएंगे, ऐसा कुछ मतलब ऐसा कुछ
हाँ
रिलेशन तो
मतलब
नहीं आ रहा है
इट वाज
कि
मोर
डेल्टा
अबाउट
बढ़ ही
माय
जाए। यस।
इट वाज मोर अबाउट माय गट फीलिंग रादर देन अ
हाँ
मैथमेटिकल इंटरप्रिटेशन या
हाँ।
प्रूफ।
बट मतलब ये समझ में आया ना कि लाइक
हाँ तो मतलब इसमें,
फॉर गिवन के। हाँ
हाँ इसमें अपन लॉग इन में ये निकाल सकते हैं ना कि क्या k की वैल्यू रहेगी।
हाँ, मतलब पहले ये समझते हैं कि के फिक्स रहेगा तो कैसे
नहीं
निकालते हैं, तो
मतलब
जैसे
सॉरी,
के फिक्स है।
मतलब
हाँ
फॉर अ गिवन k लॉग इन में हम कैलकुलेट कर सकते हैं कि सम क्या रहेगा।
हाँ। यस 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 यस, करेक्ट करेक्ट।
ठीक।
For a given k you can calculate this delta value in like finding the maximum.
हाँ मतलब हम इंडेक्स बाइनरी सर्च से मतलब इंडेक्स निकाल लेंगे और उसके
Yes,
बाद का, हाँ ठीक है।
so for a given k, like you can find this delta value, and let's say the position I am fixing. I am fixing my k, and I am also fixing this I. So all you have to do is find this delta value. Now what I'm saying is that this delta value will be nothing but the maximum suffix sum. Okay, so the maximum suffix sum. Now, the maximum suffix sum actually can't overlap with any of these lesser than or equal to zero smaller segment, right? The reason is like what I was telling you, that let's say it is forming like this, that here the sum was for the first time becoming less than k, and these were some lesser than zero segments, right? And lesser than zero, and let's say this is the your delta value which is greater than or equal to zero. So if you calculate the maximum suffix sum, it won't ever happen that this is overlapping with this segment, this lesser than zero segment. The reason is that if you consider this one, this segment, now this must be having a value lesser than or equal to zero, because if this some of these numbers are having greater than or equal to zero, then definitely your maximum prefix sum will become this and not this one, right? So this thing must be lesser than or equal to zero. Okay, the sum of all these numbers must be lesser than or lesser than zero. So so what it means is that in fact your segment will be like this. So this will be also one segment whose value is lesser than zero. And if it is so, then your next segment must be starting just after it. So it must start just after it. Now this also cannot be lesser than zero, because if it is lesser than zero, then maximum suffix sum would be rather this and not this one, because this is having a value of sum lesser than zero. Okay, so that's why the maximum suffix sum will give you this last suffix which is having a value of greater than or equal to zero. It can't ever overlap with this zero segments. Okay, so this is the thing which we will try to do. We will try to iterate on all the positions I, right? And let's say previously the value was prefix sum was p of I minus 1, and currently it is pi. Okay, currently it is pi. So previously it was p of I minus 1, currently it is pi. So what we can do, we can set our k to equal to p of I minus 1. Okay, because we want to maximize the value of k plus delta. So we will try to choose maximum k. So best will be to choose k as p of I minus 1. Okay. Now once we choose this, all we have to do is to find the maximum suffix sum in this. Okay, we try to find the maximum suffix sum which start to the right of I. Okay, and we can easily find this using multiset or binary search. So that will take you O of log n.
बट
And
कांट वी
yes,
मतलब इसमें, अच्छा तो भाई लाइक हम हर इंडेक्स को ट्रैवर्स करेंगे और फिर उसके
yes,
करस्पॉन्डिंग, बट
हाँ
मैक्सिमम डेल्टा वी कांट फाइंड इट लाइक कि हम राइट साइड से प्रीफिक्स हम लेते चले जाएं, राइट साइड से सफिक्स हम लेते
हाँ
चले
हाँ,
जाएं, और
yes
एक
yes yes,
आरे, और एक
हाँ
आरे मेंटेन कर लें मैक्सिमम का, जो मतलब
हाँ
मैक्सिमम ऑफ
हाँ,
प्रीवियस,
yes yes yes,
तो दैट वुड
yes
बी
yes yes,
ऑफ
yes
ऑफ
yes,
वन, नो?
Yeah, actually I just forgot. I have also done the same thing. Basically, you can maintain a maximum like running variable that will maintain the maximum value of suffix sum over all these positions. So you can maintain, yes, a running variable mx. So mx will so when you will be at position I, you can simply update your maximum as maximum of max and p of n minus 1 minus pi, like this. Okay, you simply take into account this suffix as well. Yes. So that will give you in O of 1. Yes.
अच्छा, okay. Like if you could just you solve it on the fourth example, मतलब जो सबसे normal example था.
Okay.
The approach of yours, yeah. Dry run अगर उस पे एक बार करते हैं.
Okay. So this is the 5, 1 minus 3, 2 minus 1 minus 2, 2. Okay. So let me see what I am printing, what k I am printing here. K is 6. K is 6. Okay, so let's first calculate the prefix sum on this. So it will be 5, then 6, then
Yeah, screen को
3,
like
then
maximize.
okay. Yes, so it becomes 5, 6, then 3, then 5, then 4, then 2, and then again 4, right?
Yeah.
5, 6, 3, 5, 4. Yes.
Hmm.
So let's say you are at this position. Okay, you are at this position. So definitely you can see that p of I minus 1 is greater than p of I. Okay, so you can simply set your k as 6, right? So if you set your k as 6, then what is the maximum suffix sum in this part?
2.
2, right? 2, because you can simply choose this as well. So your answer will be 6 plus 2 as 8. So answer will be at least 8.
अच्छा, and when do we choose मतलब k is equal to 6? मतलब जब भी we see that the next prefix sum is less than current prefix sum. Okay.
Yes. Because then only you can choose some k, because if it is greater, like there is no significance of choosing some k.
Okay.
Because as you told, or as you already mentioned, that if it is already lesser than k, like nothing happens.
Okay.
Yes.
So basically for all indexes of I, जिनके next following element हमारा prefix sum छोटा हो गया. So we are gonna take k for that value of I, right?
Yeah.
But अगर अभी मैं -3 के बाद एक 3 डाल दूं उसमें, तो 6 फिर से हो गया.
-3, if you add a 3 after this, so this
the prefix sum would become 6 again, right? And then instead of -2 I have instead of 2 I have -2. So basically what I'm trying to say is that we are gonna have 2 occurrences of prefix sum 6 which are followed by a negative element.
Yes.
तो उनके लिए different answer आएगा या same ही answer आएगा?
Like it depends कि मतलब जैसे for example in this case you are appending a 3. Okay.
5 1 minus 3 3 minus 2. Yeah.
So just give me 5 1
3 sorry, -3. 5 1 minus 3 3 minus 2, and then the rest, let's get it to the same. I'll just tell you the elements. It's -1 -2 2.
-1 where, like you were telling another array?
No, just add it to -2 in मतलब आगे -1 -2 and then 2.
-1 -2.
No, not in front. मतलब after -2. Yeah.
-1
-2 2.
Like this, right?
Yeah.
Okay, so see, like here you have to again iterate. Like first of all, calculate each of its prefix sum, like 5 6 3 6 4 3 1 3, like this. Then you can basically fix each I, and say let's say you are considering this 6.
Yeah.
So again you have to consider all the suffix sums.
So it would be give 2, right? It would give us 2.
Yes, it will give you 2. So again it will come out to be 8.
अच्छा ओके, बट जस्ट इन केस लाइक अब अगर मैं उस लास्ट हाँ ओके, द -2 at index 5, if we change it to -1,
-6.
-1,
This one.
no no, the just one before that, -2 को -1 कर दो, 3, हाँ इसको -1 किया अगर, -1,
Mhm.
तो for this 6 my maximum prefix sum would be 2 only, right?
2
Not
only,
1,
right? 2.
not 1.
2 only, yes. If you make
अगर
it 13 something very bigger, then maybe you can take this
हाँ
entire
नहीं,
one.
but what I'm trying to do here is that I want to keep it as 6, but what I'm trying to do is basically कि मैं आंसर को चेंज करना चाहता हूँ, मतलब जैसे for the 6 at
You can
index,
simply put all the negative elements, no? Then in that case, simply put all the negative elements like -1, -1, -1 like this.
okay,
Then
ठीक है,
your answer will simply remain 6.
हाँ नहीं, I was trying to say is कि अगर मेरा k 6 है at index 1, जैसे इस index 2 पे मेरा k 6 है राइट, और index 3 पे भी मैं k को 6 ले आऊँ, बट क्या मेरा फिर उसका आंसर चेंज हो सकता है क्या?
See, so that basically means you are saying that you again want to make it 6 or maybe greater than 6 as well, right? You are saying.
Yeah.
So let's say you are saying that, okay, let's say at this point of time, it becomes like 10, right? So this is having a, so if you add all these AI value, this must be greater than 0. But like this does not matter. Like at the end, you have to also add other values as well. And if let's say if adding other values make it lesser than 0, then does not
Yeah.
matter if it became 10 earlier. At the end, like you will become 6 again. So that's
हाँ
why entire
नहीं,
has to be considered.
my point being कि अगर मेरा prefix sum 6 हो रहा है right at 2 जगह, at 2 places I have the prefix sum as 6 which is followed by a negative element, तो मतलब मैं वो 2 cases consider करूंगा उस I को k बनाने के लिए right,
Yes,
और
yes.
बट व्हाट आई एम ट्राइंग टू से इज कि अगर मैं उस दोनों जगह आंसर चेंज कर दूं, मतलब डेल्टा की वैल्यू डिफरेंट हो जाए उन दोनों पोजीशंस के लिए, तो द अप्रोच दैट वी यूज टू कैलकुलेट द मैक्सिमम आंसर, वो गलत नहीं हो जाएगी?
No, it won't be like wrong because anyway, like if here it is also 6 and let's say here it is also 6. So definitely if you make 6, choose 6 here, then that will give you a better answer because you have this entire range of suffix sum. But if you make 6 at this point, then you only have this much range of suffix sum. So if some better answer exists earlier, then that would be already taken out.
अच्छा ओके, ठीक है,
Yeah.
I'll implement this. Yeah.
Yeah, so let me share the code for this. So the code. So here I am taking A and then I am calculating the prefix array as P. So prefix array is one based index. Then I am calculating this minimum. So just ignore this. There is no need of it. Then I am calculating K considering K as 0. So what is the answer? So considering K as 0, I first calculate the answer. So in that case, my result will be simply 0. Result is storing the value of K. So initially it is 0 and correspondingly I calculate the answer. Okay. Then I iterate on each of the values. So I start from the end and then I check if P of I is greater than P of I minus 1, then I can't do anything. So I continue. Otherwise, my value of K will be P of I minus 1, right? Then I calculate that maximum suffix sum. So I update it with like P of N minus P of I. So that will be the suffix sum from I plus 1 to N, right? And I check if max plus K, right? Max is nothing but delta. So if delta plus K is greater than answer, so I update my answer and I also update my K value. And at the end, I simply print the K value, which is stored in result. Okay. So this was for D.